Chapter 2. The Shape of a Thinking Thing. What do we imagine when we think about the shape of a thinking thing? It is far from trivial. Just think of other instances where shape has turned out to matter. The shape of an atom spells out its very properties and functions, and our models of it have had to shift and iterate over time to accommodate new knowledge about its behaviors. Before the architecture of neurons and their galaxy-scale interconnectivity was revealed, the brain seemed insignificant to a study of mind. The study of something so elementary as shape even has the potential to make some of the hitherto most relevant debates redundant. For example, people used to ask whether the Earth was finite or infinite, whether you could travel in one direction forever, or risked falling off one of its edges. Although it is hard for us to put ourselves in their shoes today, this is an entirely commonsensical argument to have if you assume the world to be flat. When someone comes along and suggests that the world might be round, not only does this new shape pose a solution of sorts to the question, but it renders the terms finite and infinite utterly irrelevant as categories, since both of these designations can be seen to be, in a sense, true. The Earth is finite in that it's not endlessly large, and it is infinite in that you could endlessly travel on it in one direction without ever meeting the world's edge. The shape with which we initially pictured the world set the terms for the entire debate, and only now is it plain to see how the original question itself was based on a critical assumption. Rather than simply answer it either way, the concept of a round Earth came to radically transform and even transcend the finite, infinite Earth question. It is revealing to observe in so simple an example how a question can prematurely answer itself by way of an underlying assumption, curtailing access to a more enabling inquiry. A question has the capacity to mislead research towards ends that would be made entirely redundant had the core models we used to ask it in the first place been questioned. The trouble is, it can be difficult to spot these core models. Our assumptions are just that, assumptions. They are set aside for the sake of convenience and do not enter the realm of questioning. Perhaps this is why radical reframings of debates, such as that enabled by a round Earth model, have tended to happen more or less accidentally, as a byproduct of researches into altogether different fields, and why just how radical they are tends to be more obvious in retrospect. But what if something akin to a round Earth could be applied to today's debates about agents, selves, or thinking things, debates which manifest diversely from discussing artificial intelligence to negotiating politics of identity? What if these discussions are currently arising out of flat Earth-like assumptions about the shape of thinking things? Just like the finite, infinite Earth example, the things people do and say in relation to thinking things or agents reveals that they already have a certain shape for them in mind, whether or not they reflect upon it. Let us first consider what exactly is meant by shape, before exploring how it applies to thinking things. The use of the word shape here is intended to mean something very similar to a scientific model. A model of an atom, for example, is not necessarily a visually representative picture of an atom, but a functional one, picturing the way it works rather than the way it looks. Models, like those of the atom, change over time as new observations of the phenomenon present themselves. High school physics textbooks often present the evolution of the atomic model as a linear progression, with some models finally discarded in favor of others, gradually improving our understanding of its behavior and allowing us to make better predictions about atoms over time. But the development of models is not simply linear. Even at the level of the state of the art in a given discipline, there may be several models of the same phenomenon that variously highlight some specific facet or mechanism at the expense of another. In the case of atoms, several different accepted models exist today, each highlighting particular behaviors or properties and underrepresenting others. Some models focus purely on different electron orbitals and barely feature any information on the nucleus. Others emphasize the nucleus and grossly simplify electron orbitals. The fact that each model is biased towards specific qualities over others suggests that a model can itself be thought of as a kind of character. A character is, after all, a frame. It allows us to see, but this vision always comes at the expense of what it necessarily excludes. This duality of affordance and cost is key to the understanding of character presented in this thesis. Imaginative shapes, models, or intuitive diagrams, such as the shape of the Earth or a model of an atom, are thinking tools that enable us to intuit different properties of a given phenomenon. Moreover, since they are light, portable ideas, I can flip between envisaging the world as round or flat with relative ease, and since they serve a functional purpose, they enable us to do, say, or think particular things in relation to the phenomenon, we are likely to be carrying such internalized intuitive models about all kinds of things all the time. These portable and functional properties of the model mean that we are especially likely to be carrying implicit models of things that we need to continually work with and think about on a daily basis, such as other human beings. In this chapter, we go in search of the shape of a thinking thing, which is to say, we go in search of simple thinking tools to help us intuit the mechanics of self. As with the multiple models we have available to intuit different aspects of the atom, I discuss several shapes that foreground different aspects of the mechanics of self. Rather than necessarily settle on any one of them, the diversity of shapes available to us hopefully allows us to move flexibly through our observations of the mechanics of self. I will present at least two shapes that have guided the popular imagination of thinking things: the vessel and the distributed self. The prevalence of the vessel model in particular is suggested by anthropological research, as well as a small-scale empirical study that I conducted, the details of which can be found in the third experimental report associated with this thesis, Diagramming the Self, Deriving Lay Theories of Selfhood from Drawings. In this study, I invited 104 participants to make a drawing of what they thought a diagram of the self would look like, thus providing further data on how self-mechanics are conceptualized in the popular imagination today. Following the discussion of the vessel and the distributed self, I will emphasize certain properties and behaviors that those two models do not, by proposing another shape that could add to the palette of our intuitions about the mechanics of self, the line.